Okay, so I gave you this just helpful sheet with logs versus exponents. So we're going to start to learn that they're the inverses of each other. What does the word inverse mean to you again? What happens to an xy? It turns into a yx. Okay, so exponential we know looks like this. Some base to an exponent equals a result, right? Like 3 squared equals 9. Turning that into a log base result, it equals the exponent. So in math we talk about input output. So here the output is the result, like we're normally used to, and logs make you think backwards because the output is the exponent. Does that make sense to you? The output is the exponent. So y equals base x, that's exponential. Y equals log base x is logarithmic. So in this scenario, x is the exponent and y is the result. We input the exponent and we get out the result. Here, x is the result and y is the exponent. So what do you think I did? Right? I switched x, y. Guess what we're going to do? Does this look familiar? A, B, C, D stuff. The rest of the year, all these graphs are going to have A, B, C, D stuff. So A would be in the front of it all, right? And it does a vertical stretch. B would be in front of the X, horizontally compressing. The C would be inside the variable part with the X. It will move left or right. And the D is after, moving up, down. Okay? We're just doing the same things we did. Okay, so here's an example of an exponential, and here's an example of what it would look like in log, just to make sense of it. Okay, so today we're going to learn how to graph, so you don't know this bottom stuff. On the back side, I just put down some things. You probably want to have these numbers, some of them, most of them memorized. 2 to the, you probably want to know all your 2's. So like 2 squared is 4, 2 cubed is 8, 2 fourths, 16, 2 to the 5th. Okay? I wrote down probably as much as I think that you should know. Okay? So those ones are like good to know without having to think about going into your calculator to figure that out. And then 3 rules that you need to have mastered as well. So a 0 exponent, doesn't matter, result 1. A negative exponent, remember that, goes to the bottom positive. And we talked about the square roots. So the square root of 25 is the same as 25 to an exponent, a half. The cubed root is the same as an exponent of 1/3. Okay, so that, make sure you know those 3 rules. You learned that in grade 10, but I know that you forgot it. So there is a sheet that hopefully helps you just remember some big important ideas. Okay, let's start graphing. Okay, we're going to graph y equals 3 to the x. It's in our notes. It'll be on the second page, graphing. And we're going to graph exponentials to start. Okay, so when I graph, I'm going to do 3 to the. Okay, so what is 3 to the negative 2? What is 3 to the negative 2?
3 to the negative 2 is
1 over 9, yeah. Because it's the same as 1 over 3 squared, right? What is 3 to the negative 1?
3. 1 over 3.
1 over 3. What is 3 to the 0? 1. What's 3 to the 1? 3. 3 squared, 9. 3 cubed, 27. Okay, so I'm going to graph those points. So negative 2, comma 1/9. Second page of our notes. You just draw it really close to the height of 0 without touching 0. Negative 1, comma 1/3. So I'm trying to go a little bit higher than the first point that I drew. 0, 1. 1, comma 3. And I'm actually not even going to draw anymore because they're way up there. Right, the next one is pretty high already. Okay, so this is the shape. I'm going to connect all the points together. Okay, let's talk about what's happening on the left side of this graph. What's going to go on here? If I keep going and going left and left and left, what's happening? I'm getting closer and closer to 0. What happens on a graph if we ever say we're getting closer and closer and closer? A dotted line, an asymptote. Okay, do you understand it's going to get closer and closer but not touch? Because the next would be 1/27, 1 over 81. You're getting smaller and smaller and smaller and smaller. Okay, so I have kind of 3 basic rules. You're always going to have the anchor point, 0, 1. That's always a basic point, right? Because anything to the 0 is 1. Your asymptote, how do we actually write the equation of that flat line? What's the equation of this flat line right here? Okay, I'll give you 2 multiple choice questions. Should that line be x equals 0 or y equals 0? What is always 0 on that line? The x or the y? Y. Y is flat at 0. And you're always going to have another point, 1 comma base. As in here, right? If I put the exponent of 1, the result is the same as my base was. Okay. How do you graph 1/2 to the x? Okay. What is 1/2 to the negative 2? One over 1/2 squared. What happens when you're doing that? What happens with all that flipping around? What would it turn back into? Thanks. 4. Because it flips and then goes squared, right? It's like 1 over 1/2 squared, which is like 1 over 1/4, which turns into a 1. Are you wondering just the quarter part? What's that? Yeah, the 1 squared is 1, the 2 squared is 4. Okay, what do you think about this one then?
Where did the square 2 go?
The square of 2 is 4.
Oh, I see. So
Yeah. I squared 1, and I squared 4. Or square root 2. Yeah, there's 4. What do we think this result's going to be? Negative, so there's a flip. And what's the 1? 2. Because you got to do a flip yet. The negative makes us do some kind of flip on the fraction, right?
Why is it positive? Wait. No, I got it.
Got it? What's 1/2 to the 0? 1. What's 1/2 to the 1? Keep the same, right? That's the rule with 1. What's 1/2 squared? 1/4. What's 1/2 cubed? 1/8. Yep. Okay, so let's graph those coordinates. Okay, does yours look like mine with the dots? Points are good? So I'm going to connect. So I also have, did you realize, the same asymptote? Because you're just going to be going right and down, 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 closer, closer, closer to 0. Okay, did we have an anchor point? Yeah, the 0, 1 is still there, 0, 1. What's the asymptote equation? Same, y is 0. And what's another point? 1 comma base. In this case, it was 1 comma 1/2. Okay, what do you think about the difference between our first graph and our second graph here? What's the difference between this one and this one? What's the big one thing that's different?
Well, this one is like in the left side, but press. But this one is right side.
That one starts big and goes little. This one starts little.
Okay, so this one starts little and goes big. This one you're saying starts big and goes little. Okay, I'm going to use these words. Can I say this one is increasing? Okay, so here's why we're increasing. If this base is bigger than 1, you're going to increase. That's an increasing function. Okay, and then the second graph we drew, look at my base. What am I going to write here? If the base is less than 1, I'm going to decrease. Okay, so that's a little bit of a rule. Okay, let's graph this one. Okay, so here I know my base is 2. That's what I know. That's a base. That's not an A. That's a base. Which A, B, C, D letter is that 3? That's a C. So we are going to be moving what? Left 3. And this -1 is a D. So I'm going to be moving down 1. Okay, please don't get confused. I get lots of people that think they're A and they're base. Separate those, right? That's a base. I need to have a base. Okay, So here's how I start every question. I give 3 points. I go, what is 2 to the negative 1, 2 to the 0, and 2 to the 1? That's what I do all the time. 2 to the negative 1, 2 to the 0, and 2 to the 1. Okay, so what is 2 to the negative 1? Negatives make it flip. So 1 over 2. Anything to the 0 is 1. And 2 to the 1 is 2. So I have these 3 points. Those are my 3 points that I'm going to graph, and I'm going to be able to figure out the pattern. Okay, do you see where I got those points from? The input, output. Okay, now we also know the general idea. So it's going to be increasing with an asymptote, right? Okay, now we're going to transform this thing. So I need to go left 3 and down 1. Do you remember how to write these? Should I recall here? X divided by B minus C, AY plus D. Back to that old thing, right? We're good with that still? Okay, can you move those 3 points doing what we did last unit? Okay, so you know what I like to do? All my x's. So every x minus 3. So minus 4, minus 3, minus 2. Every of those x's I minus 3. And then y minus 1. So what's a half minus 1? Negative a half. What's 1 minus 1? 0. 2 minus 1 is 1. Okay, so I'm going to graph those 3 points. So negative 4, negative a half. Negative 3, 0, and negative 2, 1. Okay, before I connect them, let's also talk about our asymptote. Here's our asymptote. It doesn't matter if I move this line left or right. Right, do you see? Left or right moving that line, it doesn't matter. But shifting that line down 1 will make a difference. So your asymptote will now be at y equals negative 1. And then here's your new graph. Okay, I guess I see a question here. I didn't even notice it. Find the Y-intercept. Okay, so here's what I'm going to do. What does a Y-intercept mean? What does a Y-intercept mean on a graph? It is where x is 0. So if x was 0, what would the math be? What is 2 cubed? 2 cubed is 8 minus 1, 7. Oh, that looks right. I think this thing is going to go up, right? I think it's going to cross there. Yeah. That would make sense. Okay, let's do some in your book together.
That's all we're looking for?
Do you want me to, Timur? Is that what you're saying?
No.
You say it like that. Like, what? That's it? I
That was
feel
hard for my brain.
like I want to give you something with an A or something with it. Oh, yep. I found a gooder. Number 14 on page 4. I've already done it, but page 4. Page 4, number 14, does it match yours? Okay, you ready? Okay. First of all, here's my suggestion. Identify the base. Identify the base. That's my first suggestion.
2 is 8.
What's the base? We got a 2 or a 4? Which one?
2.
We still got a 2 and a 4. Which one are we thinking? We all got to agree. The base is 4. The base is 4 because it's 4 to the exponent.
Wait, so
What is the exponent attached to? Which number is the exponent attached to? A 4. The base is 4.
so if there is exponent, then is the one in the middle then?
That's the most important thing. The base is 4. 4 has the exponent on it. Okay. So I'm going to just start. You ready? What are my 3 ideas? 4 to the negative 1, 4 to the 0, and 4 to the 1. I always start with that pattern. Get 3 basic points in the middle. Okay, what is 4 to the negative 1? There's a flip. 1 over 4. What's 4 to the 0? 1. And 4 to the 1 is 4. So I'm going to write them as coordinates now. Input, output. So there's 3 coordinates. That was actually on the graph. It was drawn for you. Those points should have been on that graph. Okay. Now let's talk about ABCD stuff. Okay, we got a 2. What letter? That's an A. We have a 3. That's a C. And a D. Can you write me just the general math transformation coordinate? So the X will have a +3, 2y plus 1. Remember, that's the same as last unit. Understanding that part of it? Okay, now I need 3 new points, and then I will graph. Okay, I'm going to rip through all the x's here. So -1 plus 3, 2. 0 plus 3, 1 plus 3. Okay. Ready? I'm going to do the y's. This one will be a little tricky. What's 2/4? Half plus 1, 1 1/2. 2 times 1 is 2, plus 1 makes 3. 4 times 2 is 8, so 9. Okay, before I draw this, I'm going to draw our asymptote. Normally it's here. Was there any movement that will move it? Up 1. So my asymptote will be there. And then I'm going to draw those points that I have. And how does yours look? So it should look like the points are more vertically stretched out. It should look like it has gone right 3, and it should look like it's gone up 1. Right, with our transformation talk?